Designing a direct access solution. Direct access is intended to make it easier for your remote users to connect to your network, a lot easier than the old VPN, virtual private network approach. In this nugget, we're going to be focusing primarily on the design decisions, how this thing works, where things need to be on your network. We've got another nugget coming up that's going to walk you through some of the major configuration and deployment tasks. So with that in mind, here's what we're going to cover. We'll focus on the topology that you're going to need to put in place for direct access, a lot of the prerequisites, how this thing actually works, what players are involved in this game, and so forth. We'll talk about the use of certificates because this was kind of a big deal in the old version of direct access, and it's changed a little bit with some caveats in the current version. So you're just going to want to know what you can get away with in different scenarios from a design perspective. We're also going to talk about some of the concerns from migrating from the Microsoft Unified Access Gateway. You see, in the old days, Windows Server 2008 R2 had a version of direct access, but UAG had a better version of direct access, and now Server 2012 has direct access that includes most of the betterness that was in UAG, plus it's less expensive, so you very well may want to migrate off of UAG onto 2012, so we'll talk about some of those details as well. Now we're going to start with a kind of functional overview of direct access, but as I go up through these kind of different bits, I'm going to point out some of the differences between direct access in the previous version of Windows Server and direct access in Windows Server 2012. And I'm also going to bring in some of the differences between direct access in 2012 and direct access in Microsoft's Unified Access Gateway product. You see that it was another thing you could use to implement kind of a better version of direct access, but as you're making design decisions, you do need to be aware of what's new and, frankly, awesome in Windows Server 2012, because you're not going to have to go to UAG as often as you used to. So here's the basic layout of this. You've got client computers, they connect to your home network, and they connect to the internet. You've got traveling users, maybe they're off in a hotel room or something else, they hit the internet. Wherever they are, they need to be able to get to their resources, which are located on your network. Now, the way we've traditionally done this is through a virtual private network, and you can still do that. The problem with virtual private networks is when the user sits down and plugs in, the VPN isn't on. They have to know to go in and activate it. They have to authenticate to your network, and that creates a private tunnel between wherever they are and a VPN end server, such as Windows Server 2012's routing and remote access. In fact, in one of the upcoming nuggets, I'm going to show you how you would configure this VPN connectivity, because there are times when you still might want to do that. Users don't necessarily love this approach, though, and it does create some downsides. You have to do a lot of tricky stuff to make sure that their regular traffic is, or their bound for your network traffic is in fact going to your network. But when they're sitting in the hotel and they want to access an internet site, you might actually want that to just go straight there instead of going back through your network. So that can be a little tricky to set up. But basically, the whole idea of them having to know what to click and where to click it. For example, let's say you've got a couple of sites, as I've pictured here. Let's call this the Asia site, and let's call this the US site. If a user is sitting in a hotel room, which one do they connect to? Well, if they're sitting in a hotel room in Tokyo, you probably want them to connect to the Asia site. They're going to have to know that. If they're sitting in a hotel room in New York, you probably want them to connect to the US site, but they're going to have to know that, which means they're going to have several connections set up, and they're going to have to choose between them. And we all know what happens when end users try to make choices, right? They make the wrong ones. Well, direct access is designed to stop all of this. Once direct access is installed on a computer, every time that computer starts up, direct access queries DNS for a particular record, and you can set what that is, but there is a default, and you're going to see it when I walk you through the setup of this. It queries that, and that gives it the address of a server that's running a particular web service called Network Location Service, or NLS. That is a service that is only running on your network. In fact, one of the new features of direct access in Windows Server 2012 is that NLS can run right on the direct access servers. In fact, you'll see where it sets that up when I walk you through the setup. So when it sees that the network location service is available, then the computer knows it's connected to your network, and direct access kind of fades into the background and doesn't do anything. If it's not able to reach your NLS server, then it knows it must be connected to the internet, and so direct access kicks into action and creates a connection to your network. And this happens automatically. It happens based on the user's logon credentials. You essentially install a certificate, and you can do all this through group policy, a certificate both on the computer and for the user, and those are used to authenticate the connection back to the direct access server. Now, there's one little caveat from a design perspective I need to mention right now as we're talking about that network location service. Keep this in mind. If the computer can't contact NLS, then it thinks it's on the internet and direct access kicks in. So if you've only got one server running direct access, then it can die, and all of a sudden all of your computers are going to think they're on the internet and they're not going to work properly. So that's why it's really important to do what I've pictured here, which is have redundant direct access servers. Now, as I've pictured these things, I've written RASDA. They can, and this is new in Windows Server 2012 as well, they can run routing and remote access to allow incoming VPN connections along with direct access. So you can consolidate all of your remote access stuff onto one or two machines like this, put them behind either a hardware load balancer, or I'm going to show you how to set up network load balancing, a software load balancing solution that actually runs on the servers rather than being a separate load balancer. Logically, though, it all works out the same. So you can have two of these things. They're redundant that way, and your network users, your intranet users, your local users, will always be able to see that network location service. So that's definitely a big deal. From a capacity perspective, one of these servers with 4 cores, so 4 CPUs and 4 gigs of RAM, can run about 2,000 clients simultaneously. So if you've got 2 and they're load balanced, you've got about 4,000 clients simultaneously for remote access. That's going to be enough for most organizations, especially by the time you start spreading it across sites. And oh yeah, multi-site. That's another thing Direct Access knows how to do, and I'll show you where the button is to get that setup kicked off as well. It knows which site it's closest to. So when the client is in Asia, it automatically connects to that one. When the client computer is in America, it automatically connects to your North American site. So you don't have to worry about users making a choice, because users don't always make good choices. Now, the presumption with the multi-site setup is that you do have a wide area network link of some kind connecting the 2 sites, so that if a user does, in fact, go to visit Tokyo and they wind up connecting to that one's direct access server, they can still traverse the private wide area network to get to whatever resources they might need across the entire network. So to keep that in mind as kind of a design criteria. Now, in the old implementation of direct access, these direct access servers actually needed 2 network adapters. They either had to be, a picture is going to be easier for this. I've reduced this to just one direct access server to make it easier, but this is the way you used to have to do things. The RAS server had to be connected to your internal network, and it had to be connected either directly to the internet as an edge server, which makes all of your security people completely upset, or it had to be connected to, as I've shown it here, a firewall, which forms a demilitarized zone or perimeter network. So you had to have 2 network adapters. You had to do it this way. But while you still can do that, and there's some performance reasons to do that, because it certainly lets it do incoming and outgoing traffic pretty quickly, you don't have to do it that way anymore. Now you can do what I originally showed you over here, which is have your direct access servers with a single NIC apiece, and they can use that both to talk to your clients and to talk to your network so that your clients can get to whatever it is they're after. So that is also a new capability. Now, another thing that's new, and this used to be a real driver to make people switch to, use Unified Access Gateway's version of Direct Access instead of what was built into Windows Server. The idea behind Direct Access in Windows Server was that your entire internal network needed to be running IPv6, and a lot of people really aren't. So what UAG did is it put together this a thing called NAT64, Network Address Translation 64, and DNS 64 components that was capable of wrapping the IPv6 traffic in IPv4 to send it to your internal network. Well, now, guess what? Don't have to do any of that anymore. All of that capability is built right into Windows Server 2012. So you can automatically translate IPv6 traffic into IPv4 without needing IPv6 support on your network. This is a big deal because it means you can implement DirectAccess and you don't have to make a lot of network architecture changes. So we've got the performance information, you know how to cluster this thing. This is another big deal. And this is possibly one of the biggest new features added to DirectAccess in Server 2012 is that Server 2012 can use network address translation to deploy DirectAccess and VPN using this single NIC, single IP address, and single port. Remember, before I told you you had to have, let's go back to this diagram. You had to have, where's my other diagram? There it is. You had to have two network adapters, and the idea is that this one really needed a publicly addressable IP address, and this one would be an internal IP address. DirectAccess did not like being behind network address translation, where this would be a public interface, but this would be a non-routable IP address, or non-publicly routable. It'd be a private IP address. That's gone. Part of the support for giving DirectAccess the ability to work off of a single NIC is that DirectAccess can now deal with NAT. So if you have a public IP here, your firewall or other edge device is performing network address translation, and you've only got a private IP address on your DirectAccess servers or your load balancer, now that all works. That's another important thing to keep in mind. Now let's talk a little bit about this actual connection that DirectAccess makes. When it connects from your client to your DirectAccess server, as I'm showing here, it actually creates two separate tunnels. The first is referred to as the infrastructure tunnel. And this one is designed primarily to authenticate the computer. So the first one, the infrastructure tunnel, is designed to provide the client computer with access to domain name services, so DNS, and this is on the corporate network side of things, to Active Directory, so that's your Active Directory domain services, domain controllers, any other infrastructure and management servers you need, and that can include network access protection, so your network policy servers, something we're going to talk about in an upcoming nugget actually. The second nugget is called the second tunnel is called the Internet tunnel or intranet tunnel, and it's designed to provide access to intranet resources such as your websites, your internal file shares, your application servers, and so forth. The default implementation of these tunnels relies very heavily on IP security, or IPsec, and it relies pretty heavily on IPv6 as well. So here's essentially what happens. If you don't have a native IPv6 network infrastructure, then there's a protocol called ISATAP, I-S-A-T-A-P. You'll also hear this referred to as Teredo sometimes. And it's a way to wrap IPv6 in an IPv4 packet. Now, computers that are running Windows 7 or Windows Server 2008 R2 and higher support this ISATAP host functionality. Now, you do have to put ISATAP host records in your DNS. So those are normal DNS IPv4A records. Those have to be in your DNS, and all machines can then resolve that name to configure their ISATAP adapters. Now, actually configuring ISATAP is beyond the scope of what we're going to talk about here, but be aware that you have to do that. So let's make some room here and talk about these two tunnels specifically. The first one, the infrastructure tunnel. This is constructed using the IPsec Encapsulating Security Payload, ESP, and it is built with an IP-TLS, Transport Layer Security Encryption, and it uses the machine certificate that's installed on your client computer. Now that tunnel again gets you access to your DNS server, your domain controller. It allows the computer to download group policy objects, that's important, and it allows the computer to request authentication, here's the tricky bit, on behalf of the user, because the whole point of this is we don't want DirectAccess popping up an authentication dialog for the user. We're trying to make this transparent. Now, the other tunnel, the intranet tunnel, the one that actually gets you to the resources the user is trying to get to, That also uses encapsulating security payload. The encryption is provided by IP-TLS, IP Transport Level Layer Security. This tunnel actually authenticates the user, provides access to your internal resources, and so forth. That tunnel has to come up before you can get to Microsoft Outlook or whatever else. Kind of the default way that DirectAccess used to work is by having a user certificate. So you've got separate computer and user certificates that are being used to authenticate people. This automatically created some problems for folks in the old days because it meant you had to have a public key infrastructure. You had to be issuing certificates to all of these users and computers before they left the office so that they would be able to direct access their way back in. And if you didn't want to go with your own internal PKI and all the maintenance that involves, then you had to buy certificates, which means spending roughly $7.5 billion, depending on how many users you've got, of course. So that was a big hurdle for DirectAccess. Now, in Windows 8, and this is a huge design criteria, if your client computers are running Windows 8 and you've got your DirectAccess running on Windows Server 2012, you don't have to have a PKI and you don't have to buy certificates either. Instead of using a computer certificate to establish these tunnels, it can use an HTTPS-based Kerberos proxy, essentially meaning it uses HTTPS, so the same protocol that you would use to visit a website securely, to wrap the normal Kerberos authentication traffic that would occur if you were attached to your intranet. Because HTTPS is so easily routable across the internet, it'll get there, and that will allow you to securely authenticate and bring up those tunnels. So you don't even need a third-party certificate for, well, we'll talk about this in just a second. Actually, what the heck, let's talk about it now. There's several different ways that DirectAccess can bring up these tunnels. Now, the sad fact of the universe is that the vast majority of public networks are not going to route your IPv6 traffic. Now, DirectAccess is perfectly willing to say, that's fine. Rather than relying on these tunnels natively using IPv6, I will wrap them all in IPv4 traffic, and I'll get them through that way. And that's fine if it works, but on a public network, I mean, you know how it is. You go to a hotel, you plug your laptop in, you're lucky if you can check email because they put proxies and stuff in the way, and you have to authenticate, and you have to pay your $15, and you have to type in the magic code or whatever it is. This traffic tends to just not work. So the most widely available type of thing still have two different tunnels. They're still IPsec, but they get wrapped in what's called IP HTTPS. In other words, the tunnels are just wrapped in plain old HTTPS, which is very, very easy to get through a network. Now again, let's talk about old versus new. HTTPS does provide encryption. That's one of the points of it. So in the old days, using IP HTTPS, which is what your clients were going to use most of the time, was bad on performance because it incurred a double encryption penalty. In other words, you're already encrypting the traffic in this tunnel. That's the whole point of the ESP and the TLS. You're then encrypting it again to put it into HTTPS. But for Windows Server 2012, Microsoft has come up with an interesting little fix, and it relies on the fact that the HTTPS protocol isn't about just encryption. Now, when we're using HTTPS, and you can see in the address bar here that I am using HTTPS, we're used to seeing the little lock icons pop up somewhere in the web browser, like I'm here on paypal.com, and that tells us that our transaction is safe. It tells us that our connection is safe. And what we usually think by safe is this has been encrypted, so no one can intercept our data. But that's actually only half of what HTTPS is designed to do. I mean, think about it. Let's say you have some private correspondence and you put it in an envelope and you seal it with wax so it's protected and it's all opaque. You can't see through the envelope or anything else, so it's encrypted essentially. And then you hand that packet off to a stranger. Well, what's to stop them from just cracking it open? Right? Or actually, here's a better one. Let's say you've got a little cache lockbox and you put a bunch of private documents in there and you lock it, and you're willing to just sit that around because you know it's encrypted, it's locked, no one can get in, but then you hand the key to someone who shouldn't be in there. Well, now they can just pop it open. You see, the other bit that HTTPS does is it authenticates. The remote server, in this case PayPal, and I use this one because they do this, they have handed my computer a certificate, a digital certificate that says I'm PayPal, and my identity has been verified by a trusted third party. It's been verified by, well, you saw it, VeriSign in that case right here. So there's two pieces to HTTPS: authentication, proving that the remote server is who I think it is, and encryption. And you can actually disable either one of those components. So now in a direct access environment, if you need to wrap all of this in IP HTTPS, Microsoft sets the encryption to null. It's still relying on the fact that the individual tunnels are encrypted, but it's just using this for the authentication to make sure that it's hitting the right server on the other end and to wrap these packets in HTTPS, but it's not getting that double encryption penalty anymore. So this is actually a huge upside of the new version of DirectAccess, and this is only if you're working with Windows Server 2012. Now, I've mentioned Windows 7 and Windows 8 a couple of times now, so we need to be clear on just one thing. This is something I want to make sure you don't get tripped up on. Your Windows 8 clients come out of the box equipped for everything they need to connect to DirectAccess running on Windows Server 2012. Your Windows 7 clients, and I'm expecting in most organizations you're primarily going to be dealing with Windows 7, your Windows 7 clients do not have everything they need. They need the DirectAccess Connectivity Assistant, the DCA, version 2. And that's a free download, but it does have to be downloaded and installed if you want your Windows 7 DirectAccess clients to talk to a Windows Server 2012 DirectAccess server. DCA v2 should not be installed on Windows 8. It is not necessary, so do not install there. But that'll make sure that all of your clients are able to get in. Now, if you're one of the many companies out there that's still running some Windows XP, that's too bad. And that's why, for those clients, you still may want to support the normal good old routing and remote access role, supporting some VPN endpoints so that your old XP clients can continue to use the older VPN style of connection for their remote access solution. Now, another design choice you're going to have to make is something called forced tunneling. By default, when a remote DirectAccess client creates its connection to DirectAccess, that allows it to get to your internal network resources, like a file server, web server, whatever else. But DirectAccess knows which addresses are on your internal network, and it knows which addresses are on the regular internet, and it won't use that tunnel to access internet resources. Now, the theory behind this design is it's just better performance, right? You don't necessarily, from a performance perspective, want your clients coming into your network and then back out your network to get to a resource and then have the reply coming back through your network and back out to the client. From a performance perspective, it's as ugly as this diagram. Looks like spaghetti. It's a lot of wasted back and forth. So by default, DirectAccess won't do that. However, you can configure something called forced tunneling. This means you do exactly that ugly picture. So on the incoming, whenever a client on the internet is connected to you through DirectAccess, they need to connect to an internet server like this one. They're going to go through your network to your DirectAccess server. It is going to send that request back out through your network off to the internet server. Whatever results are then going to travel that same path in reverse. Forced tunneling. Now, why in the world would you want to do this if from a performance perspective it's so awful? Well, because from a performance perspective it is awful, but from a security perspective you might want it. If you've got your firewall set up as a proxy server to do anti-malware scanning or to block access to malicious sites or unwanted sites, you might not want your computers able to just romp freely around the internet just because they left the office. You might want to say, look, we've got a lot of controls and security built into our internal network, and I want you to take advantage of those even when you're not actually on our internal network. So I'm going to force all of your traffic to come back through the internal network just so that we can take advantage of this. Now, from a design perspective, if you're going to do that, it probably makes sense to go with this type of deployment instead, where you've actually got direct access sitting in the DMZ. You want to put as few steps as possible, in other words, between your client and your direct access server. So you're burdening the overall network just a little bit less, and it's still not awesome from a performance perspective, but it's less not awesome than the other way. So there are some different design choices that you're going to have to make that way. And another design choice, I mentioned earlier how direct access can now be deployed without a public key infrastructure or the use of third-party certificates. That is still a recommended architecture. While direct access is capable of providing a self-signed certificate for this whole thing to work so that you don't have to have PKI or third-party certs. And by the way, when I show you how to set this up, I'll show you the checkbox where you have it generate a self-signed cert. Even though it can do that, it's still not recommended. And if you're going to do things like forced tunneling or other certain deployment scenarios, having a PKI is still a requirement. If you want strong authentication, you need a certificate deployed out to your client computer, so having PKI is still going to be necessary. If you want to integrate this with network access protection, so that a user who's out on the internet comes into direct access, your network access protection architecture realizes, hey, this guy doesn't have the latest patches. I don't want him actually talking to the network. I'm going to restrict his access to a subset of our network where he can get the latest patches and update his antivirus definitions and everything else. So that's what network access protection does. And if you want to integrate that with direct access, you're going to have certificates, which means you're going to have a PKI. So there are some dependencies between some of these features. While you can get a very simple direct access deployment up with no PKI and with self-signed certificates, the recommendation, and for full use of all of direct access's capabilities, you are still going to have a PKI on your network. Direct access also now offers something called a simplified deployment mechanism. And when I run through the little setup wizard, you'll see where it lets me pick that. Essentially, the simplified one is the one where you don't have a PKI. You're using self-signed certificates, so that's one of the things it gives you is that capability. And it also gives you the capability of, well, not the capability, it can change direct access's behavior so that it no longer requires 2 tunnels, but only requires 1. Now that means the direct access server only has to maintain 1 IPv4 address for incoming connections. It means that each client isn't taking up 2 sets of encryption. They're only doing 1 set of encryption. And so you can support slightly more load, and it's a slightly bit easier to configure your direct access server. Now, Microsoft pitches this primarily at small and medium-sized deployments rather than large ones. Some large deployments like it because it lets them put more load on this server too. So you kind of have to be the judge of that. Again, though, in this simplified deployment model, you don't get all of the features because you're not using PKI, for example. Forced tunneling doesn't become an option. Something like integrating NAP doesn't become an option, and so forth. So in this simplified model, what do you need to make sure happens? Well, on your firewall, you've got to make sure that the IPsec ports, and that's UDP, 500 and 4500. You got to make sure those are open and can get to the direct access server. In addition, TCP 443, right? If you recognize that, that's the good old SSL, HTTPS protocol. That's got to be open, and it's got to be able to get through to the direct access server. The direct access server should have a server authentication certificate for TLS issued by a certification authority, like either your internal PKI or a trusted public CA, and that CA needs to be trusted by your direct access clients. So this can be a public certificate. It doesn't require an internal PKI deployment. If you don't have a certificate installed on the direct access server itself, then the setup process we go through will configure a self-signed certificate, and that's necessary for that IP HTTPS tunnel that we were talking. That was awful. IP HTTPS tunnel that we were talking about earlier. So that'll deploy as a self-signed certificate. Continuing with the list of things that the simplified doesn't support. There's just a couple more I want to make sure I mention. And these are ones that may kind of become important to you. So they can't handle, that deployment can't handle two-factor authentication with smart cards. You lose multi-site, as well as the NAP integration and the forced tunneling. So if you need all of those features, you're still going to have to deploy the two-tunnel mode. Now, the last thing we need to discuss are the basic steps involved in migrating from a unified access gateway setup to an RAS direct access setup on Windows Server 2012. There's really two different approaches you can take here, and we'll cover them both, but they're vaguely similar. The first is side by side, and that means you're essentially running two parallel direct access implementations, one on UAG and another on Windows Server 2012, which are these guys down here. And you migrate your users from one to the other. This involves a couple of extra steps, but it does allow the entire infrastructure to stay online the entire time. This means everything stays running, all your users are good to go. After the deployment, your direct access clients can access all of their internal resources via 2012, and you shut down the UAG server. So the basic steps. Step one, you have to get your direct access configuration settings exported out of UAG. Now, if it's deployed in an array, then you want to do this on the Array Manager server. So you get your settings exported. Step two, make a note of the name of the group policy objects that are used for direct access, including the server GPO, the client GPO, and, if relevant, any application server GPOs. So I guess we can put some words up here. Settings, GPOs. Step three, set up your Windows Server 2012 computers, that's these guys, as a remote access server by installing the remote access role. So, remote access. Step four, configure all your infrastructure settings on that remote access server. Give it its IP address, its DNS settings, its certificates, client security groups, settings. Next step, and as we've talked about, you're going to have a certificate on these machines. Now that's for your IP HTTPS. That can either be self-signed, or you can get a certificate from a CA, which is the same thing you did in UAG. And that's the trick here. If you have UAG, you already had a certificate. So you might as well get a certificate and use it here, because once you start using certificates, you get more of the direct access features, as we've been talking about. So step 5, cert. Step 6, groups. You're going to need to set up an Active Directory security group that contains the computers that are allowed to be direct access clients. And you're going to see how to do that in the next nugget. Step 8, get your GPOs. And the direct access installation wizard will set all this up for you, but you need to make sure you do it in all the relevant domains. And then finally, make sure all of your UAG settings get migrated to your new direct access infrastructure. Then your users are just going to start going over there. So you're going to change your GPOs so that it points your users at your new servers instead of the old ones. And once you're sure everyone's gotten those GPOs, you're done with your migration. Frankly, the other migration mechanism or approach, the offline approach, is almost exactly the same thing. You take this down. Now, all of your users can no longer get in, and you set this up. Most organizations, honestly, are just going to do the side-by-side approach. You're going to set these up, let users continue. Here, let's get rid of some stuff. You're going to set these guys up, let your users continue hitting your UAG. Once these are set up, you're going to take UAG offline, change your GPOs, let everybody get the new GPOs, and as they do, they'll start coming over here. Once nobody's hitting this thing anymore, you just take it off. So, not too complicated. Microsoft kind of makes a big deal of the migration, but when you actually dig into the documentation, it's basically set this up the same way you always did, change your GPOs, and take this offline. It's not all that difficult. And with that, I think we've gotten everything. You've seen how direct access works, and you've seen the different topology components that are going to have to be in place in order for you to make direct access work. I've tried to approach this in a way that helps you understand different business goals and what design decisions meet those business goals, because everybody's going to have slightly different criteria for how they want this thing deployed. We've particularly talked about the use of certificates and how having a PKI is still a recommended solution, but how you can get away with not having a PKI and what you're going to pay for in terms of lost features by doing that. And we looked briefly at some of the concerns and steps involved in migrating from the UAG version of DirectAccess to the version of DirectAccess that's in Windows Server 2012. I hope this has been informative for you, and I'd like to thank you for viewing.